I am sure you have all played the tug of war at some point or the other. Here it is teachers versus the students. Seems like the students have managed to win this one. They were definitely the stronger team. At the end of the day, strength counts. Do you know that a similar pull and push occurs in atoms which share electrons? How? Keep thinking. Still thinking about the push and pull in atoms? Well, before we delve into that, let's take a look at what we will study today. Today we will study about the hydrogen bond and its effect on properties of molecules. Then we will deal with the abnormal properties of water and the meaning of resonance. Last but not the least is exam decoded, our recipe for better scores. All of us are unique in some way. You may be a wonderful singer or a very good writer. So what is unique about hydrogen? Well, it has only one electron. As a result, it can either lose or share its electron. In hydrogen molecule, the two atoms of hydrogen form a covalent bond by sharing electrons. Both the hydrogen atoms share the electrons equally. But what happens when hydrogen forms a bond with other atoms like oxygen, halogen, nitrogen or carbon? In such a case, the electrons in the covalent bond will not be shared equally. Can you guess why? In the beginning of this show, we saw a tug of war. Why did the students win? They were stronger, right? Similarly, oxygen, nitrogen and fluorine atoms exert a stronger pull on the shared pair of electrons than hydrogen. This is because they have greater electronegativity than hydrogen. So the stronger atoms manage to get a greater share of electrons from the weaker hydrogen atom. Electronegativity is the property of an atom pulling the shared pair of electrons towards itself. Due to the difference in electronegativities of the two atoms, polarity is introduced in the covalent bond and the resultant bonds are called polar covalent bonds. In these bonds, the atom which gets the greater share of the electrons develops a partial negative charge. Hydrogen, on the other hand, develops a partial positive charge. The electronegativity of fluorine, oxygen and nitrogen is greater than hydrogen. When either of them bond with hydrogen, it develops a partial positive charge. The electronegative atoms, on the other hand, develop a partial negative charge. When such a molecule appears within the vicinity of another molecule, the hydrogen atom with its partial positive charge will attract the negative end of the other molecule. This weak bond is known as the hydrogen bond. Thus, we can define the hydrogen bond as the attractive force which binds the hydrogen atom of one molecule with the electronegative atom of another molecule. Take a look at the graphic. You will notice that the hydrogen atom here has two bonds. One bond is a covalent and the other one is a hydrogen bond. The hydrogen atom acts like a bridge between the other two atoms, doesn't it? I am sure you have a science club in your school with members from different classes. Clubs like these are a good opportunity to bond with students from other classes and sections. In fact, they are like the hydrogen bond which links different molecules together through its intermolecular bond. When compared to a covalent bond, the hydrogen bond is definitely weaker. As a result, it only affects the physical properties that are dependent upon the intermolecular forces and not chemical properties. So how does hydrogen bonding affect the properties of compounds? To begin with, it affects the boiling point. As we know, boiling point is directly proportional to the molecular mass of a compound. However,
Ammonia, hydrogen fluoride and water have higher boiling points in spite of their lower molecular weight.
Can you guess the reason? That's right. It is due to the presence of hydrogen bonds, as it takes more heat energy to break these bonds. Hydrogen bonding also affects the molecular mass. Molecules show higher molecular mass when they are linked by hydrogen bonds.
We know that organic acids have COOH groups. Their hydrogen atom, which is bonded to oxygen, is positive enough to form a hydrogen bond.
The two molecules bond together to form a structure known as dimer. As a result, the molecular mass is double of what we expect.
Likewise, hydrogen fluoride also has a much higher molecular mass than what we would infer from its formula.
Hydrogen bonding also leads to increased viscosity, and greater the number of hydrogen bonds, greater is the viscosity. An example of that would be glycerin. It has 3 hydrogen bonds holding 2 molecules together, thereby leading to a higher viscosity as compared to water, which has 2 hydrogen bonds. Let me demonstrate this. So you see, water flows while the glycerin does not, due to higher viscosity. In a similar vein, compounds possessing hydrogen bonds have a higher surface tension as well. Because of the ability to form hydrogen bonds, molecules of the compound stick together, and this leads to a higher surface tension. Water and alcohols with OH group are good examples of such compounds.
We inherit a lot of traits from our parents. If you belong to a family of tall people, you are also likely to be tall. Reason? Good old genes.
Wondering at the relation between genes and hydrogen bonds? Well, you can find hydrogen bonds in the linkages of DNA strands that make up the genes. It is also important in other biological systems like the linkages of peptide chains which form proteins. Speaking of tall people, you are sure to find a lot of them in a basketball court.
After a game of basketball, you end up sweating profusely. And that is a good thing, because once the sweat evaporates, it cools your body down, and this happens due to the high heat of vaporization of water.
Because of its high heat of vaporization, water absorbs quite a lot of heat from the surroundings to reach the gaseous state, and in the player's case, it would be body heat. Many plants and animals also use this property as the basis of their natural cooling system. It wouldn't be wrong to say that it is the hydrogen bonding in water that makes it a unique substance with many unusual properties.
For example, water is a universal solvent, that is, it can dissolve a large number of substances in it. This is because water can form a hydrogen bond with another water molecule or with other molecules. And as we have just seen, water also has a high boiling point, high heat of vaporization, and high surface tension. All of these result from its ability to form hydrogen bond.
Time for me to take a break with a refreshing glass of water. In the meantime, let me see if you can crack this question. Name a few biological molecules which have hydrogen bonds. Keep thinking while I take a short break. Welcome back. So do you have the answer to my question? I had asked you to name a few biological molecules which have hydrogen bonds. The answer is water, proteins, DNA and RNA. I hope you have grasped the different aspects of hydrogen bonding that we have discussed so far. Also, you must never stop asking questions because they make all the difference to the answers you might give in your exams. Take the example of our young caller for today.
Could you please explain me how ice floats on water?
That's an intelligent question and a probable one for the exams too.
Ice looks heavier than water, but in reality, ice is less dense than water owing to its cage-like structure resulting from hydrogen bonding. This structure has large vacant spaces in between, which decreases the density of ice. However, in water, which is a liquid, such a cage-like structure is not present. Hence, the molecules are closer to each other and density is more.
You know that for the same amount of mass, volume is inversely proportional to density. Now, can you use this concept to tell me why pipes burst in cold regions? The answer is simple. When water freezes, it is converted to ice, and ice being less dense than water, it will lead to increase in volume, thereby causing the pipes to burst. So far, you have seen how structures arising from hydrogen bonding affect the properties of compounds. Using one such structure, I will now show you another interesting property called resonance. Let's take the example of carboxylic acid.
When a hydrogen ion is removed from this carboxylic acid, we get a carboxylate ion. This ion has two oxygen atoms, and both these atoms have a high electron density because one has a negative charge and the other has a double bond. The electron pair forming the double bond shifts to the oxygen atom. As a result, this oxygen atom develops a negative charge and a double bond is formed between the other oxygen atom and carbon. You should remember that this movement of electrons lowers energy. This phenomenon of delocalization of electrons resulting in more than one structure is called resonance. The two structures formed as a result of resonance are called canonical structures and have similar energy. The actual structure of a molecule is a hybrid of these two structures and is called a resonance hybrid.
These molecules which show resonance have more than one structure to represent the same molecule. Let us explore how this happens.
If you were to look at ozone, the resonance structure would differ only in the distribution of electrons, and the electrons which are part of the resonance hybrid would be delocalized over 3 oxygen atoms. Such electrons are known as delocalized electrons.
What is the average height of students in your class? Let us assume that it is 5'7". Does it mean that every student in the class will have the same height? No, it only represents the average value. Similarly, resonance averages the bond characteristics as a whole. Molecules which show resonance do not show the properties of other multiple bonds. Most ions, like sulfate and nitrate ions, stabilize by resonance. As a result, they are stable in solutions.
Sulfate ion has 6 resonating structures and is very stable. Nitrate, on the other hand, has 3 resonating structures.
Canonical structures have higher energy than the resonance hybrid. This is due to the delocalization of the pair of electron forming the multiple bond. You must remember one thing. Canonical structures have no real existence. However, there is something else which has a real existence. I am talking about exams. But don't worry, I will be back with Exam Decoded for your aid after this short break. Welcome back. So all set for Exam Decoded? But before that, let me take you through a quick recap of what we have learned till now.
We began with the definition of hydrogen bond. It can be defined as the attractive force which binds the hydrogen atom of a molecule with the electronegative atom of another molecule like fluorine, oxygen or nitrogen. We also saw that hydrogen bonds can affect physical properties like boiling point, surface tension and viscosity of the compounds. We learnt about resonance shown by molecules having multiple bonds and that the stability of a resonance hybrid is always greater than the stability of any of its canonical structures.
Now that you are armed to meet the challenge of exams, let's head for Exam Decoded. Welcome to Exam Decoded, your gateway to great scores. Let us begin with the rapid fire round. The magic number here is 5. You need to answer 5 questions correctly to get 5 marks and you have precisely 5 seconds to answer each question. Your first question is, water has unique properties due to A. Hydrogen bonds, B. Resonating bonds, C. Ionic bonds, D. Coordinate bonds. Correct answer is A. I'm sure that you got this one right. Let us move on to the next question. 2 structures are resonance structures if they differ only in the location of A. Double bonds, B. Triple bonds, C. Non-bonding electrons, D. All of the above. The correct answer is D. Now the third question. Water doesn't freeze from bottom upwards in water bodies because ice is denser than water. True or false? The answer is false. That should have been easy if you had been listening to me earlier in the show. The next question is a multiple choice one again. Which of the following has the highest boiling point? A. NH3, B. PH3, C. ASH3, D. SbH3. The answer is A because ammonia has the strongest hydrogen bonding amongst these. Now the last question. Glycerin has high viscosity because of covalent bonding. True or false? The answer is false. Let us now compare scores. If you scored all the 5 marks, congratulations, you are a high flyer. If you got 4 or 3, you are an achiever. Anything less than 3 means you are a learner. However, these scores are not the final word. You can certainly improve your performance in the exams by logging on to www.topperlearning.com and practicing tests and getting your queries resolved. In companies, employees get increments in their salary if they work harder. As far as we are concerned, our incentive is marks. So, how important is this chapter? The chapter Chemical Bonding and Molecular Structure has a weightage of 5 marks. This makes it critical for your exams. For the incentive of 5 marks, you need to put in some hard work to answer questions that will test your knowledge ability. So what are the questions that you can expect? Mostly, you might get short answer type questions of 2 or 3 marks. For example, you could be asked a 2-mark question. The boiling point of ethanol is 78.5 degrees Celsius and methoxymethane is minus 24.8 degrees Celsius, even though ethanol and methoxymethane have the same molecular formula. Explain the reason. As the first step, you should explain the reason for the higher boiling point of ethanol. Ethanol has a higher boiling point because of its ability to form hydrogen bonds, whereas in methoxymethane, hydrogen bonding is not possible. You know that ethanol has a hydrogen atom which is directly attached to a highly electronegative oxygen atom. This results in hydrogen bonding, which is a strong intermolecular force. As a result of this, more heat is required to separate its molecules. This much will get you 1 mark. For the other mark, you must write about methoxymethane. The hydrogen atoms of methoxymethane are not bonded to highly electronegative atoms like oxygen, nitrogen or fluorine. Because of this, there isn't sufficient positive charge to form a hydrogen bond. So, ethanol will have a higher boiling point. There is nothing like expert guidance to help one get out of a tricky situation. So let's go over to today's expert for some tips.
Hydrogen bond is basically an electrostatic force of attraction between hydrogen and an electronegative atom like fluorine, oxygen and nitrogen. There are two types of hydrogen bonding. One is called intermolecular hydrogen bonding, which takes place between two different molecules, and in intermolecular hydrogen bonding, it takes place between different groups of a same molecule. They are normally represented as dotted line, whereas a normal covalent bond is represented as a dashed line. This hydrogen bonding can affect the physical properties, but they are not strong enough to affect the chemical properties. Now come to resonance. What is resonance in one line? Resonance is movement of electrons, movement of pi electrons and lone pairs. You must remember when you write the canonical forms that all the forms must have correct number of valence electron.
Those tips are definitely going to make exam stress a lot more manageable. As a final tip, here is some food for thought. Have you ever tried mountain climbing? To reach the summit, you need to climb one step at a time. Exams are also like that. Work throughout the year and you will be able to score very well in your finals. It's time for me to bid adieu. Till next time, goodbye and good luck.